Okay, so first of all, I taught you uniform and non-uniform motion also, that is completed. Then we have done acceleration also. Today we will do graphs of motion. Okay, let's do this topic.
Okay, ma'am.
Graph of motion. I hope you see my screen.
What, ma'am?
You see my screen, right?
Yes, ma'am.
Okay, so Atheeb, the first question that we do is the first type of graph that we will study is distance, time, graph. You know what is the distance time graph? On the x-axis, you will be plotting the distance, the time on the x-axis, and on the y-axis, you will be plotting the distance. Okay, x-axis you plot the time, y-axis you plot the distance. Now, for example, you have this type of graph. Okay, so here you have the time, here you have the distance, and let's suppose you have a straight line like this. Okay, you get a straight line like this. So this line is the slope now, right? This line is the slope. So slope of
Yes, ma'am.
time graph. Now tell me, now what is the formula for slope now? We know slope is y-axis divided by x-axis, right? Now what is y-axis? Y-axis is distance. And what is x-axis? That is time. Now tell me one thing, Atheeb. What is distance divided by time give you?
Our speed.
Speed. So that is why, can I say that the slope of the distance time graph will give you the speed?
Yes, ma'am.
The slope of distance time graph gives you speed. So please quickly note this much down. Are you noting along with me only?
Yes, ma'am.
Okay. So the slope of the distance time graph will give you the speed. Note that thing. The next that we have is, you can note down this point as well. The slope of distance time graph can be used to calculate the speed of the body. Okay. Now we will focus on some unique different types of distance time graphs. The first one is distance time distance, and let's suppose you have a straight line. Okay, so this is a uniform motion. Okay, this is for a uniform motion. Why it's uniform motion? Because you see that the the slope is a straight line. Okay, that is why the speed is constant. The speed is constant. Okay, so that is why this is a uniform motion. Next is for a non-uniform motion. What kind of graph will you have? Straight line, the y-axis, x-axis, this is distance, time, and now let's suppose you have this kind of line, a hyperbola. So this is non-uniform motion. Non-uniform motion. Okay, so these are the two graphs. You also have a third graph, the distance time graph. You draw the y-axis, the x-axis, Now let's suppose you have a straight line like this. So what does it mean to have a straight line? So straight line means your speed is zero, right? That is only see. What is the meaning of straight line now? That your distance is not changing with respect to time. Atheeb, focus on the class, child. What does it mean to get a straight line parallel to the x-axis? Straight line parallel to the
Ma'am, that
x-axis.
means the thing is the speed is 0.
The speed is zero. So that is why it does not have any motion. So this speed is zero. So
Okay,
these
ma'am.
are three kinds of graphs that are there in your syllabus: uniform motion, non-uniform motion, and straight. Next is, let's suppose this is the question. Have you noted this much?
No, ma'am, I'm noting them.
Note it down.
And ma'am,
Now you can also note down one point. Steeper slope means high magnitude of speed. That means if you have a very steep slope, that means your speed is also more. Okay. So let's suppose I give you a question like this. The question is, this is the distance time graph. Time. And you have four objects now. And it is B, A, D, C. And the question is, distance time graph is shown. Which of the following is correct statement regarding the motion of these cars? Okay, so first option is car A is faster than D. Car A is faster than car D. B option is car B is slowest. C option is car D is faster than car C. And fourth is car C is slowest. Okay, Atif, now look at this question very carefully. I told you the statement that steeper the slope means higher the magnitude of the steep slope. Steep slope means, for example, look at these slopes. So B is the least slope. Okay, it is very less steep. A is steeper than B. D is steeper than A also, and C is the steepest. So what do you think will have the highest speed?
ma'am, C.
C has the highest speed. Okay, C has highest speed. Now then after that, so after car A, so for the most speed is of car C, then of car D, then of car A, and then of car B, right? So which is slowest and which is fastest? Which is slowest and which is fastest?
Ma'am, slowest is B and fastest is C.
Exactly. Now look at these questions. Look at these options. It says car A is faster than D. Is it true or false?
Ma'am, it's false.
Okay, car B is slowest.
Yes, ma'am, true.
True. So this is only our correct option. Car D is faster than C.
Yes, ma'am.
Car D is faster, you think?
Ma'am, car D is slower, ma'am.
Yes. Then car C is slowest. True or false?
Ma'am, false.
Okay. Now the question is, you can take a screenshot of the question. You only note down the class notes, and for the questions you will take a screenshot so that we save class time. Quickly take a screenshot.
Okay, ma'am. And ma'am,
Okay. The next question is displacement of an object is proportional to square of time, then object is moving with, the options are uniform velocity, second is uniform acceleration, third is increasing acceleration, and fourth is decreasing acceleration. Now look very carefully. What is the question given to you? Atheeb, please focus on the board. The question says displacement of an object is proportional to square of the time. Now look here. Can you tell me the formula that has displacement also and time also? What are the three equations of motion?
V equals U plus AT.
Okay. Then
S equals U plus 1 by 2 into AT square. UT plus 1 by 2 into AT square.
then
Then 2AS equals to V square minus U square.
yeah, V square is equals to U square plus 2A. Now what happens? Can you look at the formula and tell me which one of them has displacement also and time also? The first, second, or third one?
The second one.
The second one. So that means I will work on with this equation now because the question says about displacement and time. Now look at this formula. S is equals to ut plus half a t square. Now look at it, Atheeb. What do we have in the question is when is the displacement proportional to time square? That means I want this value and I want this value. Other things I don't want. So first of all, let's try to make it 0. That means our velocity should be 0. Okay. Initial velocity is 0. So S is equals to half kt square. Now, when is the displacement proportional to t square? When this a value is a constant, it is not changing. When this a value is constant, then S will directly be proportional to t square. So, when a value is not changing, that means it is uniform acceleration. Okay, you understand this?
Okay.
Take a screenshot quickly. Is it done?
Then ma'am.
Okay, the next question is a student draws a distance time graph for a moving scooter and finds that a section of the graph is horizontal line parallel to x-axis. Which of the following is correct about the section of the graph? First is scooter has uniform speed in this section. Uniform speed. Second is distance is the maximum in this section. Third is distance is minimum in this section. 1 second. Okay. The question says then distance is minimum. And fourth is distance is zero. Distance is zero. Now what happens? Look here. The question says that you have a graph, and in the graph the line is actually parallel to the x-axis. So this is the x-axis, this is the y-axis. X-axis is time, y-axis is displacement, right? Now tell me one thing. If you have a parallel line horizontal to the x-axis, horizontal line parallel to the x-axis, so what do we have? What does it mean? Is your displacement changing? Is your distance changing?
Ma'am, distance is not changing.
Distance is not changing, exactly. So the correct answer will become distance is zero. How come distance is maximum when it's not changing with time only? It's not even minimum, and even we cannot talk about the speed. Speed, what I mean, is the speed uniform or is the speed zero?
Ma'am, speed is not uniform.
No, speed is zero. For see, we studied three graphs, right? We studied for uniform speed, we have a straight line.
Yes,
For
ma'am.
non-uniform, we studied this, and for zero speed, we studied this.
Yes,
This is
ma'am.
uniform speed, this is non-uniform, and this is zero speed, right? So there were three different graphs. So this graph is for zero speed. So these all are false, and only the fourth one is true. So please copy it quickly.
Okay, ma'am. Done, ma'am.
Okay. So the next thing that we have is velocity time graph. The second graph is velocity. Atheeb, you have next is velocity time graph. So what's happened since velocity time graph? What is the x-axis? The x-axis tells you the time, and the y-axis tells you the velocity. Okay, do you understand this?
Yes, ma'am.
Okay, now let's suppose you have the first cases. Let's talk about slope also now. What does the slope tell you? The slope is actually the acceleration. The slope will give you the acceleration. So Atheeb, the slope of distance time graph was speed, but the slope of velocity time graph is acceleration. Okay, remember these 2 points. Next, case 1 is for zero acceleration. When your acceleration is only zero, so you don't have a slope only, that means your graph is somewhat like this, a straight line. Your speed is not changing. This is time, this is velocity, and according to this acceleration is equal to 0. Okay.
Yes,
Case
ma'am.
2 in your syllabus is for uniform acceleration also. So uniform acceleration is how much? You have a y-axis, the x-axis. If you have a straight line like this, then it means uniform acceleration. Then let's suppose you have non-uniform acceleration. Okay, in uniform acceleration also we have more cases. Now let's suppose a situation. Your initial velocity is 0. See, in this case, your initial velocity is 0, right? See, what
Okay,
is
ma'am.
your initial velocity? Initial velocity is 0. But Ateeb, let's suppose there is a situation where your initial velocity is not 0. Then what type of graph will we have? My graph will start from this point. So if you have a graph like this is also uniform acceleration, but here the initial velocity is not 0. This is time, this is velocity, and the graph tells you the acceleration. Okay, right, Ateeb? Let's
Okay,
suppose
ma'am.
one more case. Let's suppose you have uniform acceleration only, but uniform acceleration can also be the case when your velocity is decreasing. So let's suppose your velocity is decreasing. So you will have somewhat like this graph. This is also uniform acceleration, but with decreasing velocity. So decreasing acceleration. The acceleration is uniform only, but velocity is decreasing. So this is velocity, this is time, and this is when uniform acceleration, but when velocity is decreasing. So for uniform acceleration, you have how many cases? 3 cases.
What, ma'am?
For uniform acceleration, you can have 3 kinds of graphs. For zero acceleration, you have one graph, which is like this. For uniform acceleration, you have 3 graphs. When initial velocity is 0, when initial velocity is not 0, and when velocity is decreasing. Okay, so you can draw them.
Okay, ma'am.
First, draw the graph of zero acceleration. Did you draw it? Write these points also quickly, velocity, time graph, and everything. Yes, Dave, did you copy or not?
Yes, ma'am. I did the first 2.
First, for uniform, no, just copy first one. Then, so this is A part. Then B part is uniform acceleration. For uniform acceleration, you have 3 cases, right? Case 1, case 2, and then you write case 3. Okay.
Okay, ma'am.
So number 1 point is zero acceleration, you draw the graph. Then number 2 point is uniform acceleration. And uniform acceleration, you write case 1, case 2, case 3. Case 1 is initial velocity is 0. Case 2 is uniform velocity, initial velocity is not 0. And case 3 is when velocity is 0. Okay.
Then, ma'am.
Yes. Noted. Okay. So next we come is non-uniform acceleration. Non Okay, non-uniform acceleration, there's just one graph only you have. The velocity, the time, and like this. This is for non-uniform acceleration, just draw it. Done.
And
Now note the next thing. Now you have a question. So question is, happening, 1 second.
what is this?
Okay, look here. So the first is you have this portion, and then this portion of it. And I say this is O, A, B, C, D, E. This is time, this is speed. So 6, 5, 4, 3, 2, 1. This is 4 seconds, 0 seconds, 4 seconds, 10 seconds, and 16. This is the graph with you. Now, what are the questions that follow up these graphs? So the first question is, what type of motion is represented by OA? So can you tell me what is the motion for OA? Look at line OA. This is the line.
So A is uniform acceleration.
Uniform acceleration. Very good. Uniform acceleration. And what kind of uniform acceleration? There were three cases, right? Initial speed 0, initial speed not 0, and uniform acceleration with increasing velocity or
Initial
decreasing
speed
velocity.
0.
Yeah. Then
Initial speed 0.
initial speed is 0. Okay. Then question number 2 is, what type of motion is represented by AB line? Look at AB line and tell me.
Acceleration equals 0.
Exactly. 0. Then I say BC by BC line. What kind of motion is there by BC line?
Not uniform acceleration.
No, but uniform acceleration of what kind? Here the uniform acceleration was positive.
Going down.
Positive acceleration. Here you have uniform acceleration, which is negative. Okay. Then question 3 is, find out the acceleration of the body. Acceleration of the body. So one by one we will find the acceleration. So we will first find the acceleration of OA. So look at OA. So for OA, we know the formula for acceleration is the y-axis divided by the x-axis. So what is the y-axis now? For OA, what is the y-axis? 6.
6.
Y. What is the x-axis?
4 seconds.
Right? So you get 1.5 meter per second square. For AB, we know for AB the acceleration is 0 meter per second square. Then for BC, what is the acceleration?
Negative 1.5.
Why negative 1.5?
It's going down.
Going down, okay. But why negative 1.5? How come you say 1.5?
Because it
It's not
has this
necessarily the same. Okay, what is the y-axis for it? For B,
6.
the y-axis is 6. See,
Yes,
actually, one thing you should note down is for B, you take the y-axis, so that's 6. Then for C, what is the y-axis? What is the y-axis for C? What is the y-axis for C?
0. Y
So
0.
take 6 minus 0 divided by, what is the x-axis for B?
16.
For B. Actually, take first for C, you take. Wait. You take like this. First for C, 0 minus 6 divided by, what is for C? 16. What is for B? 10. This is how you do it. So you get minus 6 by 16 minus 10 is how much? 6 only.
Minus 6.
Negative 1 meter per second square.
Okay, ma'am.
Okay, so you get minus 1.1 meter per second square, not minus 1.5. See, Atheeb, how do? You take the final minus initial. So, like, look at this point, BC point. What is final? Final point is C. So first you will take C y-axis for C minus y-axis for B. Then you take x-axis for C minus x-axis for B. This is how you will take.
Okay, ma'am.
Alright. Okay, next question is calculate retardation of the body. Retardation we also calculated. Then find out the distance traveled by the body from A to B. So distance from A to B. See, distance is equal to the area of the slope under the graph. So this whole area. Can you tell me how can I calculate this area now?
To find area, you have to find y-axis into x-axis.
Very good.
Means
X-axis into y-axis.
E into DE.
So DE is how much?
6.
6 seconds. And what is this y-axis? 6 only. So 6 into 6 is
6.
36. So the distance traveled in BC is x-axis into y-axis 6 into 6 36 meters. Okay. So Atheeb, now very neat and cleanly you are supposed to copy all of this. Okay. Just copy.
Okay, ma'am.
Yes, Atheeb, done. Shall I move ahead? Look at these questions. Have you copied these ones also?
No, ma'am, I only copied that table.
Okay, copy the table. So I'll scroll down. You can copy these questions one by one and solve.
Okay, ma'am. Done, ma'am.
Yeah, copy the questions also. Now you can copy this part, the acceleration for all the cases.
Okay, ma'am. Done, ma'am.
Okay, so now we shall move forward. Next question is, see, this is another graph that is given to you.
10 more minutes.
You have this graph. This is the speed. This is the time. O, A, B. Like this, okay? This is P, Q, R, S, T. Okay. Now what is the question? In the speed time graph for the moving object, the part which indicates uniform declaration of the body. So we will one by one study all of these parts. Now see, Atheeb, you have a speed time graph. So tell me, what is PQ representing? What kind of motion? What kind of acceleration? PQ has what kind of acceleration, Atheeb?
Ma'am, zero acceleration.
It has zero acceleration. Then what does QR has?
Ma'am, uniform acceleration.
QR has uniform acceleration, positive or negative?
I'm positive.
Positive. Okay. Then what does RS has?
Uniform deceleration.
Uniform declaration. And so you know now your answer is RS. And what is ST?
ST is also zero acceleration.
Zero acceleration. Right? So that's your answer. Next is, you have a velocity time graph like this. A, B, C, and D. 10, 20, 0, 30, 40. This is 8, 7, 6, 5, 4, 3, 2, 1. Okay, so it is given to you velocity time graph of the body. Find velocity of the body at point C. Velocity at C. So tell me, how can I find the velocity at C? This is a velocity time graph. So velocity is the y-axis. So what is the y-axis at point C?
40.
It's 40. So velocity at C is how much?
By 20.
How much? Velocity is 40
20.
meter per second.
Yes, ma'am.
Then acceleration between A and B. Between A and B. So between A and B,
20,
this is AB.
20 minus 0 by t.
Very good. 40. No. First of all, you take y-axis. So final is 40 minus 20. A is at 20, right? By
Yes,
B minus 0. So you get 20 by, no, 20 by 3. Right? So
yes, ma'am.
acceleration is 20 by 3 kilometer per hour. Then the next question is acceleration between BC. Tell me between BC what is the acceleration. This you can directly tell me now.
Zero acceleration.
Zero acceleration. Okay. So this is how we can solve it. Next question is what type of motion is represented by the following graph? So I will draw the graph. You have to tell me the kind of motion. Tell me for first and second what kind of motion is it?
First one is uniform motion. Second one is body at rest.
Uniformly accelerated motion. It's not just uniform motion. You will write uniformly accelerated motion. Okay. For the second one, you will say zero acceleration or constant speed. Okay. Uniform acceleration or constant speed. Then for the third one, like this. So third one is speed, time, a motion like this. So this is what kind of motion? What kind of motion, Atheeb?
Uniformly uniformly decelerated motion.
Yeah, negative acceleration. Very good. Uniformly deaccelerated motion. Now the last one is speed, time. Draw a graph like this. This is what kind of motion? This is non-uniform. Now tell me, non-uniform retardation or acceleration? What is it? Is it non-uniform retardation or acceleration? See, the velocity is decreasing.